All right, I think we can get started. So, hello everyone, my name is Ziyang. You can also call me David. So, welcome to today's workshop. Today, today I will be talking about the AWS Lambda. First, let me share my screen. Okay, so. So today's topic is AWS Lambda. So we will cover the concepts of the serverless, since AWS Lambda is a serverless computing service, and also the concept of the Lambda function and some use case of the Lambda function and the pros and cons of the Lambda function. Okay. All right. So before we introduce the Lambda function, let me quickly walk through the idea of the serverless. Okay. So let's start by comparing the traditional server-based architecture the with the serverless architecture. Okay. So the two like representative service here in the AWS are the Amazon EC2 and Amazon Lambda, where EC2 is a server-based architecture and Lambda is serverless. So let's see for the server, let's introduce the service first. So let's say we want to host our code somewhere. So if we choose EC2, like the server-based way, then we have to provision and manage EC2 instance, which is the virtual machine on the cloud. So EC2 has fixed resources, which means that you need to think about how many CPU and memory you need before you deploy your code. Like you need to plan everything since it's now easy to scale up or down. Also, you need to pay for the instance as long as it's up, including the idle time, including the time that your code is not running or not serving. So, like, for example, imagine you are running an online store. Like during the peak hours, like Black Fridays, you might need more resource to handle the traffic. But during the off-peak hours, you still need to pay for those resources, even if they are not being used, since it's not that easy to scale up and down. So this is like where the traditional server-based architecture, it can be a little bit hassle, but let's move to the oops, why am I serious? No, uh, so let's move to the serverless way, uh, like AWS Lambda. So serverless doesn't mean that there is no machine to host your code. Like your code is still running on a machine. However, the AWS hosts and manage the server for you. So you don't need to like provision or manage servers by yourself. And it scales up automatically based on the usage. Uh, and the availability and fault tolerance are built in, which means like less overhead and maintenance for you. Besides, you only pay for your usage, so no idle time costs for example, if your online store use Lambda, like during the peak hours, uh, the AWS automatically scale up the resource to handle the traffic. And when the traffic drops, AWS scale down the resource and you only pay for what you use. So this flexibility can save a lot of cost and reduce the management overhead. So a question in the chat, Lambda has a lot of advantage. Why will someone choose EC2? So we will talk about this when we talk about the pros and cons about Lambda function later, okay? All right, so let's continue. So why we go serverless? Or let's say, what benefits do we get as a developer if we choose the serverless way? Like no server to manage and the building ability and fault tolerance means that you don't have to worry about setting up or maintaining the servers. Like AWS ensure that your codes run reliably and is available when needed. And AWS take care of the infrastructure for you. This means that you can focus more on developing your applications and your code, and this give you a greater agility and speed up your application's time to market. It scale automatically with usage, so you don't need to think about what happens if your application suddenly get a lot of traffic. AWS will handle it for you. Also, you pay for the actual usage, not the idle time, so it's saving a lot of cost. So imagine you have small piece of code that need to run whenever someone uploads a file to your website. With serverless architecture like Lambda, you don't need to keep the server running all the time just for that. Instead, Lambda will automatically run your code when a file is uploaded and then shut down. Now we have a rough idea about the by serverless and the benefits of the serverless computing. Let's return to our topics, AWS Lambda. So what is Lambda? So this is the intro from the AWS. So AWS Lambda is a serverless event-driven compute service that lets you run code for virtually any type of application or backend service without provisioning or managing servers. And you can trigger Lambda function from over 200 AWS service and software as service applications, and only pay for what you use. Okay, so AWS Lambda is a serverless architecture. It released in 2015, and it called function as a service. So which means you write your code, you set up the triggers, and then the AWS handles the rest. The great thing about Lambda is that AWS offer a free tier with 1 million requests per month for free. And that is actually a very high volume, and it's event driven, and we will talk more about that later. Now let's dive into the two core components of the Lambda. So Lambda have two main components, which is the event source and Lambda function itself. The event source is this could be the AWS service or custom application that publish events. For example, an event source could be a file upload to an S3 bucket or a new message in SQSQ. So when this event occurs, they trigger the Lambda function to execute. And the Lambda function itself, so this is your code that process the event. You can write it in Python, in Node.js, Java, and other languages. So you can think of Lambda function as a small focused piece of code that does one job, such as resizing an image or processing a piece of data. So when an event occurs, the Lambda automatically run your function and you only pay for the compute time you use. Let's talk more about the event source. So in general, there are two different event models for invoking Lambda functions. One is the push model, where event source directly trigger the Lambda function, like API gateway or S3 upload event. Another is the pull model, where Lambda pulls the event source, like streams of data, and process the event as they arrive. So understanding these models can help you to design your Lambda function for different use cases. And there are also different invocation models. So the event model is like how to trigger the Lambda function, and the invocation models is how the Lambda function reacts when triggered. So it can be synchronized, asynchronized, or stream-based. So synchronized is like, for example, you call your Lambda function directly from your application to perform a task and wait for it to complete. Uh, Imagine you have a web application where a user clicks a button, and this action triggers a Lambda function to process some data and then uh, return the result. And asynchronous is like triggering the function based on certain events like data changes or file loss. An example would be a Lambda function that process log file uh, that uploaded to S3. So whenever a new log file is uploaded, the S3 event triggers the Lambda function to process the log file, but it will return the finished signal directly and then run the things in the backend. So this is synchronized and asynchronized. Synchronized, you need to wait for it finish, but asynchronized, like it will just tell you, okay, I'm gonna work on it, and then it's gonna work it in backend, so you don't need to wait for it finish. So you don't need to wait for it finish in the asynchronized model. And Lambda had the built-in retry if failed. And stream-based, this is the special invocation model normally used with pull event models. So it can use Lambda to process some streaming data. It could be like process the real-time data streams from the service like uh, Amazon Kinesis. For instance, like you might have a stream of data coming from IoT devices, and the Lambda function can process this data in real time. Now let's combine these two together. So basically the relation between the event models and invocation model is that event model is about how to trigger the Lambda function, while invocation model is about how the Lambda function reacts when triggered. And we can use a combination of them to perform different tasks. For example, the push model with synchronized invocation is like API gateway get requests from user and then trigger the Lambda function and then wait for the response until the Lambda function finish. Or push model with asynchronous invocation. For example, uh, the file or logs upload to S3, S3 trigger the Lambda function, and user don't need to wait for it complete, but the function will run it in the backend. Or the pull model, which I mentioned, is normally combined with the stream-based invocation, which allow Lambda to pull the data source and process the new data. And then let's talk After the event source, let's talk about the Lambda function. So let's break down the structure of the Lambda function. So first, of course, the handler function. So the handler function is the entry point of your Lambda function. It's just like the main function in Python or Java. Like the handler function like has two key parameters or two key elements, the event object and the context object. The event object contains information about the triggering event. This is the key object we need to play with when using the Lambda function. And the context object provides the methods available to interact with the runtime information. Uh, so this allows you to handle the event data and control the function's execution context effectively. So when we write the Lambda function, normally we just have a like put our main logic in this Lambda handler and then play with this event object. So it's normally a JSON format structure. And then uh, here are some like use case for Lambda. For example, the file processing, like using, we can use like AWS S3 to trigger the Lambda function for real-time data processing after a file upload. So imagine you have a website where users can upload photos and Lambda can like automatically resize and optimize the photos as soon as they upload it. For example, when user uploads a high resolution image to your website, and then it actually upload to your S3 bucket, and then the S3 event triggers a Lambda function to create a multiple resized version of that image for different display purpose. And then this image will send back to users. So you only need to pay when the function is triggered. So if there are like no image upload, then you don't need to pay for it. And another example is like stream process, like if handling the data streams from service like Amazon Kinesis. For example, you can process and analyze the social media feeds in real time to gather some insights. So imagine you have a stream of tweets coming from Twitter, and Amazon Kinesis collect these tweets, and a Lambda function process them in real time, like analyzing the hashtag and sentiment to identify the trending topics, and then store in a DynamoDB. And the user can query the data from the DynamoDB. So here, actually, we use Lambda, AWS Lambda and DynamoDB, and both of them are serverless. And also we can use Lambda to build some small web application. So we can combine Lambda with other service like DynamoDB, S3, like we can combine them together to build dynamic web or mobile applications. So you can build a serverless web application where Lambda handle all the backend logic and DynamoDB stores the data and S3 serves the static content. For instance, you might build a simple web application about the weather. So user will interact with the front end host on S3, submitting the request by clicking a button, and that button actually send request to the API gateway, and then the API gateway triggers the Lambda and then load the data vector from the DynamoDB and then send back to the user. So everything here like S3, API Gateway, Lambda, DynamoDB, they are all serverless. And this kind of setup is scalable and cost effective. And since they are serverless, so it's easy to maintain. So I would say Lambda function is more like a glue, which that connect different services. And I actually use Lambda function a lot in my works as well. Uh, One example is for the event management. You know, every time we have new events like this workshop, right? So we need to post them to different platforms like Discord, like Meetup, like Eventbrite, right? So we have like a group of Lambda functions which can pull the event info, like the event time, event description from the Notion page, and then create Zoom links, Google Calendar reminders, and also post the event to different platforms. So everything here is just powered by the Lambda function. And like after I finish all this code and deploy it to Lambda functions, like I don't need to maintain the infrastructure things at all. I just leave it there and then other people can use it to post all the events. And it only charged when it being triggered. Like it only get charged when we are posting events. And for if we don't use it, then it's free. So it's very convenient and cost effective. So after we know the use cases of the Lambda function, let's look into the pros and cons of the Lambda. So we already know the good things about it, like cost effective, scalability, like no need to maintain the infrastructures for we can focus more on the codes and it can integrate with other AWS service. But it doesn't mean that there is no limitation for Lambda and it's suitable for any use cases, right? So it still has some limit. The first thing is that the cold start. The cold start means that Lambda function can experience delays during the first invocation after being idle. So it will like affecting user experience during the first few requesting after a long idle time. It just like, when you want to drive your car in the winter, it just needs some time to warm up your car. So sometimes this can this kind of delay can affect the user experience. And then it's the execution time limit. So I think Lambda has a 15 minutes limitation. So which means that it's not suitable for the long running tasks. So imagine you have a huge data processing task, or you have a big machine learning model need to train, which only takes, which will like take around hours to complete. So then this kind of task is definitely not suitable for Lambda function. So in this case, you might need to use the EC2 to do it or use other AWS service. And also limit control is that like since the infrastructure is managed by the AWS, so you have the limit control of the infrastructure, or let's say the hardware stuffs. So like if your application has some specific hardware requirement, for example, your application needs a GPU or something, then you may need to consider other service. or require a super powerful CPU or something else. So these are some like limitations for Lambda. So in general, like Lambda function is not suitable for some heavy tasks that like the task needs a lot of computing powers and take a long time. But for some light operations, light tasks, it's a it's an ideal choice. Okay. So in conclusion, like no matter uh Lambda or EC2, like server-based or serverless, like um my opinion is that they are just tools. So every time before we start a project, like we need to think about what is our final goals, think about the use cases, what kind of task we are facing, and then we can choose the right tools. And the good tools can always help you to make things more efficient and can make your application more perfect. Okay. So this is the general introduction about the AWS Lambda. Thanks for listening. If you have any questions, feel free to ask. Welcome. Uh, get a demo. Okay. So you wanna, see, okay. So you wanna get a quick demo like how to create a Lambda function? Okay. 1 second. Let me log into my AWS console. Okay, since we still have some time, let me do a quick demo, like how we create the Lambda function. Okay. Um, Share my screen again. Okay. So after we log into the AWS console, we can go to the Lambda, and here we can just create function, and we can create from scratch or blue points. I'm gonna use a blue point so to create a simple hello world function, and we can play with different language. Here the blue points set only Python. Uh, like here it has .NET, Java, Node.js, Python, Ruby, like different language. Let me use blue point hello world function and give a function name. Let me demo. Right. Okay, so here we have just the demo function from the Lambda function. So this is the the where we write our function. As you can see, normally we are playing with the event. So event event is like if we go here, it is always the JSON format. It contains different uh you know infos. For example, uh for example, like if you trigger by S3, then it contains the path to the S3 bucket, the path to the file, something like that. And when it get triggered, I can just do a test run here. It just return, for example, return event key 1. Here the test function is, and after is follow the read is done. No. So this is just a sample uh, event. Let me test it. So in here, we return the event key 1. So it just return hello David. If it's key 2, then it should be this is the lambda. So it's very easy. Like if you know like how to write Python, then it's easy for you to get uh start work with it. And also like Lambda function had the monitor, it, which is the CloudWatch logs. So here we like you can always check the logs. Like here we have the print in our code, print value 1, value 2, value 3. And then in the back, in the CloudWatch log, we can check, you know, the backend log here. So this is the monitor of the Lambda, and the trigger, like here, we can connect with API gateway and S3, SNS, SQS, CloudWatch logs, and I think we can set it with the point drop, which is the event bridge. So, so here you can just use the coin drop to make it your Lambda function like run regularly. And you can, let's see, here we can edit the memory. You're gonna use the timeout. As I said, I think it's maximum 15 minutes, right? And if we want to, for example, connect with other service, like we also need to go here to manage uh, the role, the execution role, which give it permission to, for example, load the data from the S3 bucket. Okay. So, and this, like you can edit your code in the console like this, or you can also edit your develop your code uh on your local in your own IDE, like Visual Studio Code or some or PyCharm, and then you can put everything like your code, your dependencies in a zip file, and then deploy it from the zip file. Or you can deploy it from like upload code to S3 bucket, and it can deploy from the S3 bucket. Okay. So this is the quick setup about the Lambda function. welcome. Well, I think why it's hyped is like because sometimes meeting the infrastructure things is uh it's boring or it needs some extra time. But like your code, if your application or your code just used for some uh simple purpose, like put it on Lambda, like it's very convenient for you. Can it be done in terminal? Uh, you mean deploy the Lambda function in the terminal? Yeah, you can do that using the AWS CLI. So the AWS CLI also have uh the command to create and deploy the Lambda function.
Okay, thank you, Ziyang. Thank you for this uh, show us the AWS in these sessions. And I think that's all for today. And if you still have any questions, we're gonna stay here just for a few more minutes. Just if you have any follow-up questions. And also, meanwhile, I do post a link on for the YouTube channels. So we do have previous sections on our YouTube. And if you want to learn more about the career, and also I share the career guide because we are academies. We are helping our students to do the career switch transitions from no tech background to the technical role, and all upskill yourself to become a specialist. And you can go to our website, which is wecloudData.com, to learn more. And if you like any of these courses, feel free just fill out your contact information. Our advisor will contact you. Okay, thank you everyone. Thank you, Zian. And wish you guys have a good weekend and enjoy the weather.
Thank you, guys.